What NASA found on Titan, the mysterious moon that could harbor life. Beneath the thick orange clouds of Saturn's largest moon, Titan, lies one of the greatest enigmas of our solar system. It's a world that feels strangely familiar, almost like Earth, yet remains alien in every sense. For decades, its surface was hidden from our eyes, buried beneath layers of haze and mystery. That was until NASA found a way to pierce the clouds and uncover the secrets waiting below. And what they found changed our understanding of what a habitable world could truly mean. The first glimpse of an alien world. Our first close encounter with Titan happened in 1979, when NASA's spacecraft Pioneer 11 flew by Saturn. Its mission was simple: study the gas giant and its mesmerizing rings. But scientists were particularly interested in one of Saturn's many moons, Titan. Discovered back in 1655 by Dutch astronomer Christian Huygens, Titan has long captured human curiosity, and for good reason. It's huge. Larger than Mercury and about 50% wider than Earth's moon, Titan isn't just another rock orbiting a planet, it's practically a world of its own. But when Pioneer 11 turned its instruments toward Titan, all it saw was an endless orange shroud. A thick, impenetrable haze blanketed the moon, blocking any view of the surface below. Yet that haze itself turned out to be fascinating. The probe's sensors detected an atmosphere rich in nitrogen, just like Earth's. But there was more: hydrocarbons. These molecules, combinations of carbon and hydrogen, are not just found in fuels like propane or gasoline. They're also the essential building blocks of life. DNA, proteins, carbohydrates, everything that makes us alive, are based on carbon chemistry. And if Titan's atmosphere was filled with such compounds, it hinted that this frozen world might hold more secrets than we ever imagined. A world of weak gravity and endless flight Pioneer also helped measure Titan's gravity, and the results were surprising. Despite its massive size, Titan's gravitational pull was weaker than expected. That meant Titan wasn't as dense as a rocky world. It had to contain large amounts of ice beneath its surface. The combination of thick atmosphere and low gravity makes Titan unique. In fact, if you wore a wingsuit there, you could leap off a cliff and literally fly like a bird, gliding indefinitely through its dense air. For NASA, this realization was thrilling. It meant that Titan's skies and surface could one day be explored not just by orbiters, but by aircraft. But the 1970s were just the beginning. NASA had to wait for technology to catch up before they could truly explore Titan. That moment finally arrived 25 years later. The Cassini-Huygens era, revealing Titan's secrets. In 2004, after a 7-year journey through space, the Cassini spacecraft entered orbit around Saturn. This ambitious mission, led by NASA, the European Space Agency, ESA, and the Italian Space Agency, was designed to unlock the mysteries that Pioneer and Voyager had only hinted at. Cassini carried advanced radar and infrared instruments capable of seeing through Titan's dense clouds. Over the next 13 years, it would make 127 flybys of the moon, mapping and studying its atmosphere and surface in stunning detail. What Cassini revealed was beyond imagination. Titan turned out to be the only moon in the solar system with a thick atmosphere, about 4 times denser than Earth's. This dense blanket of gases creates a reverse greenhouse effect, trapping the cold and blocking what little sunlight reaches Saturn's distant orbit. As a result, the surface of Titan is unimaginably cold, around 179 degrees Celsius. Methane, which on Earth exists as a gas, behaves like water on Titan. It evaporates, condenses, and rains down, forming lakes, rivers, and even seas of liquid methane and ethane. In other words, Titan mirrors Earth's hydrological cycle, but with liquid natural gas instead of water. It was the first world ever discovered, besides Earth, with stable liquids on its surface. Touchdown on another world. Cassini's greatest achievement came in January 2005, when it released a small lander named Huygens, a tribute to Titan's discoverer. The probe was designed to parachute through Titan's atmosphere, capturing images and data as it descended toward the surface. For 2.5 hours, Huygens drifted down through Titan's skies, slowly revealing an alien landscape. First came the mountains, bright ridges separated by dark valleys. As it descended further, cameras revealed river channels carved into the terrain, shaped by the flow of methane rain. Finally, Huygens touched down in what appeared to be a dried-up riverbed. It bounced gently, slid a few centimeters, and came to rest. What it saw next left scientists speechless. The surface of Titan looked hauntingly familiar, like a river delta on Earth. Smooth, rounded stones scattered across a sandy plain. Only these rocks weren't rocks at all. They were chunks of solid water ice, frozen so hard they behaved like stone. Even the mountains towering above were made of water ice, not rock. In that instant, Titan transformed from a distant moon to a mirror image of Earth, frozen in time and sculpted by alien chemistry. The methane cycle and Titan's rainy seasons. However, one mystery remained. Where was all the liquid methane? Huygens had landed in a riverbed, but there was no flowing liquid in sight. Later analysis revealed that Titan's methane cycle is incredibly slow. Because sunlight is weak so far from the sun, evaporation happens at a snail's pace. The thick clouds above can hold vast amounts of methane vapor for centuries before finally releasing it as torrential rainfall. In short, Titan experiences centuries of drought, followed by brief, violent, rainy seasons that reshape its surface with flash floods. When Cassini observed Titan over its long mission, it noticed that the liquid methane was mostly concentrated around the North Pole, forming massive lakes and seas. Lakes, seas, and an alien ocean. The first body of liquid discovered was named Ontario Lacus because it closely resembles Earth's Lake Ontario in shape, though it's about 20% smaller. This methane lake stretches across 15,000 square kilometers, yet remains eerily still. Its waves rise only a few millimeters high, creating a surface as smooth as glass. But Titan's true marvel lies farther north, an immense methane sea called Kraken Mare. Covering an area of 400,000 square kilometers, it's almost as large as the Black Sea on Earth. It even has tides caused by Saturn's gravity, with the sea level rising and falling by nearly a meter. These features prove that Titan is geologically and chemically active, not a dead, frozen world. Cryovolcanoes, ice that burns Titan, also hosts another incredible phenomenon, volcanic activity. But these are no ordinary volcanoes. Since Titan's crust is made of ice, not rock, its volcanoes don't erupt with molten magma. Instead, they spew out a slushy mixture of water and ammonia, a natural antifreeze. Ammonia, formed from nitrogen and hydrogen, was abundant in the early solar system. On Titan, it still exists beneath the surface, where it mixes with water ice to create subsurface oceans that remain liquid despite the extreme cold. Scientists believe Titan's interior has a solid, icy crust, a slushy middle layer, and below that, a vast ocean of liquid water resting atop a rocky core. That means Titan has both water and organic chemistry, two essential ingredients for life. Could life exist on Titan? Titan offers a tantalizing possibility. With its rich hydrocarbon atmosphere, underground ocean, and dynamic surface, It may possess all the conditions necessary for microbial or chemical life to exist, if not now, perhaps in the past. It's unlikely that anything complex swims beneath Titan's icy crust, but even the discovery of primitive bacteria or self-replicating molecules would rewrite everything we know about biology and the uniqueness of life on Earth. For NASA, Titan represents not just a mystery, but a potential second origin of life. The next step, NASA's Dragonfly mission. To explore this alien world further, NASA has planned an ambitious new mission, Dragonfly. Set to launch in 2028 and arrive at Titan by 2034, Dragonfly is a nuclear-powered drone, a flying laboratory capable of gliding through Titan's thick atmosphere and landing at multiple sites. It will collect samples, analyze chemical compounds, and search for signs of biological activity. Unlike past missions that only orbited or landed once, Dragonfly will fly hundreds of kilometers, hopping from one location to another in search of answers. It's a bold mission, the first of its kind, and humanity's best chance yet to determine whether life could exist on a world so far from the warmth of the sun. A familiar stranger, Titan remains one of the most hauntingly beautiful places we've ever discovered. It is both alien and familiar, a frozen reflection of Earth, sculpted not by water, but by methane and ice. When we look at Titan, we're reminded that the recipe for life, carbon, hydrogen, nitrogen, oxygen, exists throughout the universe. And if those ingredients can come together on a distant moon orbiting Saturn, then perhaps, somewhere out there, life is not the exception, but the rule.